Hi, my name is Katie Butler, and this is Lab 1, discussing constant velocity motion. The objectives of this lab were to record an object moving with constant velocity and to analyze its motion, to analyze the captured video with Tracker, extracting position versus time data of the experimental model, to set up a computational model with the use of VPython that reflects Newton's second law, and also to compare the computational model with the experimental model by using Google Sheets. Some assumptions made during this lab were that the F net, or net force, is equal to 0, meaning that the object does not accelerate, giving it an acceleration of 0 meters per second squared. Also meaning that the final velocity should be the same as the initial velocity. In this case, mass does not affect velocity since the F net is 0. In order to demonstrate Newton's second law and the motion of an object moving at constant velocity, I rolled a billiard ball across a billiard table. I recorded its motion with a camera and then opened it with Tracker. I first selected which parts of the clip I wanted to use. Cutting out the beginning and end portions are necessary in order to demonstrate constant velocity. For example, during the beginning part of the clip, a force is being applied to the ball, causing it to accelerate. The net force here is not 0, and therefore the ball is not moving with constant velocity. The next step was to choose the coordinate system. Since the ball is moving along the x-axis in the negative x direction, the ball has a negative velocity. The negative sign does not affect the magnitude of the velocity, but rather merely denotes the ball's direction. After I adjusted the coordinate system, I dragged the calibration stick to the ball. I pulled the ends to the edges of the ball in order to get the ball's diameter. The theoretical value of 0.05715 meters was also entered for its diameter. At this point, I was able to begin tracking the ball's motion by pinpointing its center of mass in each frame. This showed the ball's displacement for each given amount of time. After tracking the ball's motion, I had the experimental values of position versus time. The next step was to demonstrate the ball's constant velocity by using VPython. I had to change some of the values such as the ball's velocity, initial position, and duration of time in order to reflect the ball's motion. Notice delta t is very small in order to show the complete motion of the ball. However, it does not truly matter for this experiment since the ball is moving with constant velocity. Also, the ball's mass is not significant here either since the net force is 0. I then extracted the data from this computational model in order to put its data into Google Sheets along with the experimental model's data. The experimental model's data vary slightly, meaning the net force was not exactly 0. The ball could have been accelerating due to friction or air resistance. The computational model illustrates that the ball moves with constant velocity in the negative x direction, since the line has a constant negative slope. Some important codes that were used in VPython showed the net force that equals 0, the ball's velocity, and the ball's position, making it possible to extract position versus time data. Some questions we might have were, how would the results change and how will they remain the same if you were to flip the axes? Well, the magnitude of the velocity would stay the same, but the sign would merely flip since it would be now moving in the positive x direction, giving it a positive velocity. The next question is it possible for you to say how many pushes and pulls are added together to give 0 net force in the case that you observed? No, it's not possible because in my model there are too many variables to say how many pushes and pulls are added together to give 0 net force. There could be forces due to friction, air resistance, and possibly gravitational force if the table wasn't level. In conclusion, this lab demonstrated Newton's second law of motion and showed that the ball moved at constant velocity since there was no acceleration, showing the final velocity is the same as the initial velocity.